All right, welcome to The Explainer. Today, we're going to decode the internet's addressing system to answer a really fundamental question. How does anything you do online find its way directly to you?
Really think about that for a second. You stream a movie, you load a web page. How in the world does that little packet of data know how to navigate the entire globe to find your specific screen and not, the one next door? The scale is just staggering. You've got phones, laptops, smart TVs, heck, even refrigerators all online. You've got to have a system, right? A super precise, super reliable system, kind of like a global postal service, but for data. So what's the secret sauce? Well, the secret is the IP, or Internet Protocol Address. This right here is the solution. Every single device that hops onto a network gets one of these unique numerical IDs, and that's its digital postal code. It's that simple. Now, you might think this address is just a random jumble of numbers, but nope, it's actually got a really clever structure, just like a real-world address that helps get information where it needs to go super efficiently. So let's crack one open and see what's inside. A classic IP address is basically split into two main parts. You've got the network part. Think of that as the street name. It tells the data which neighborhood to go to. Then you have the host part. That's the specific house number, telling it exactly which device to knock on. Street, then house. It's simple, but it's brilliant. But here's where the story gets interesting. This system, which we call IPv4, was designed a long time ago, and it had a huge hidden flaw. The folks who built the early internet, well, they just couldn't have imagined the explosion of devices we have today, and that led to a really big problem. You see, the original IPv4 system could only ever create about 4.3 billion unique addresses. Now, that sounds like a massive number, right? And back then, it was. It's kind of like a city starting out with 7-digit phone numbers. It works great for a while, but once everybody gets a cell phone, you are going to run out fast. So what do you do when you run out of numbers? You invent a whole new system, a much bigger one. We move from the familiar, kind of short addresses of IPv4 to this beast, IPv6. Yeah, it looks way more complex with numbers and letters, but that complexity is exactly what makes it so powerful. And when I say powerful, I mean mind-bogglingly so. Just get a load of this. The number of possible IPv6 addresses is so huge that you could give a unique one to every single atom on planet Earth, and you'd still have addresses left over. This thing has totally future-proofed the internet. We are not running out again. Okay, so problem solved, right? We've got infinite addresses. Well, not so fast. There's another really cool layer to this whole thing. Right now, as you're watching this, your devices are using two different kinds of addresses at the same time. And to get it, just think about an apartment building versus the individual apartments inside. First up, you've got your public IP. This is the one single official address for your whole network. Your internet service provider gives it to you. It's the main street address on the front of the entire apartment building. It's the face your network shows to the world. But of course, inside that building, every single device, your phone, your laptop, needs its own address too. That's where your private IP comes in. It's like your specific apartment number, say apartment 5B. These addresses only work inside your local network, and they let all those devices share that one single public IP. So who's managing all this back and forth? That's your router. It's basically the digital lobby man for your building. When a data packet, the mail, arrives at your building's public IP, the router grabs it. It looks at the name on the package, sees it's for, say, your laptop, and then delivers it to the laptop's specific apartment number, its private IP. It's a clever little process that makes your whole home network possible. All right, we're getting close to the full picture here. We know our devices need these private addresses, but how do they get them? Do you have to, type it in every time you connect your phone to the Wi-Fi? Thankfully, no. See, it happens in one of two main ways. Most of your gadgets get what's called a dynamic IP. It's temporary and it's assigned automatically. But some really important devices, they need a static IP, one that's permanent and set by hand. It's the difference between getting a temporary hotel room and owning a permanent office. And this chart really nails the why. Your router runs a little service that acts like a hotel receptionist. When your phone connects, it just walks up and says, "I need a room." And the router hands it a temporary key, a dynamic IP. It's easy, it's efficient. But for something like a network printer or security camera, you don't want its address changing all the time. You need a permanent office with a name on the door, a static IP, so everyone else on the network always knows exactly where to find it. Okay, so let's tie this all together. Here are the key things to remember. 1. An IP address is your device's unique digital postal code. 2. We're all slowly moving from the old, limited IPv4 system to the practically infinite IPv6. 3. Think public IPs as the building address and private IPs as the apartment number. 4. Your router is the lobby man, making sure mail gets to the right apartment. And 5. Most of your devices get a temporary hotel room address, while important stuff gets a permanent office address. Now, we've talked a lot about your router being this local lobby man, right? And that's a perfect way to think about how it handles addresses inside your network. But its role in the grander scheme of the internet is actually even bigger. Which leaves us with one last big question. If your router is just the local lobby man for one building, who's out there on the digital streets directing traffic between all the buildings across the entire city? Who are the real traffic cops of the internet? We'll explore that in our next explainer. Thanks for watching.